2015, paper 2, question 9. This is quite a long question. So there's all sorts of bits in it. So the heights of a random sample of 1,000 students were collected and recorded. Tick one box from the table below to indicate how you would categorize the type of data collected. So this hasn't come up in a while, but it is important to understand the differences between these. So you'll find them in your book and go over them, or just look them up online somewhere. So when you're looking at heights, that's definitely numbers, so we know it's numerical. Categorical in these two sections here. Ordinal will be things like words that are in order, like January, February, March, April, May. They are in order. Monday, Tuesday, Wednesday, Thursday, they're about the only ones, and the seasons, they're the only ones I can think. Nominal might be like your colour of cars, red, yellow, blue, white. They're just nominal. Numerical, obviously, to do with numbers. So continuous means that can you squeeze in another height in between two people? So you can always get another little height in between them. Discrete would be there was 5 cars or 6 cars or 8 cars. So you can't have 8.5 cars. That would be an example of discrete. So your answer there then is continuous. Is that okay? So height measurements can be any number on a line, and discrete would be something like 7 cars. But you can always squeeze in another bit between two heights, making it continuous. Okay, moving on to part B. The sample of 1,000 students was made up of 500 boys and 500 girls, and the data from the 500 girls was used to create the information shown in Table 1. Use the information in the table, so part 1, to estimate the mean height of the girls using mid-interval values. So your mid-interval value is somewhere in between those two, and the way you get them is 145 plus 150 divided by 2, which will give you your 147.5. So I've just done that there just to make sure you know how to find your mid-interval. So it's halfway between those two. So I've put in all my mid-intervals there, all the way along, halfway in between each of those intervals there. So to find the mean then, you have to multiply the number here, the frequency, by the mid-interval value, and add it to this number multiplied by that number. So 15 multiplied by 147.5 plus 48 multiplied by 152.5 plus 80 multiplied by 157.5, and so on. Divided by, I did put down all of those numbers there, but I should have known that there's just 500 girls. So I didn't necessarily need to do that, but the top line should come out as 82,215 divided by 500, which gives you a mean of 164.43 for the girls. That's their mean height, 146.43. Remember that we're going to use that number a little bit later in the question. What is the largest possible value for the range of the heights of the girls in the sample? So the largest possible value, when we're looking at this here, we don't actually know if there is a girl who's 145 centimeters high. The smallest girl could actually be 149 centimeters. We don't know. But to make the largest possible value, we can say there could be one who's 145 and there could be one who's actually 185. So we get the difference between those two. Sorry, it's a bit hard to see. The difference between those two, 185 minus 145, gives you an interval or a range of 40. Next one there. Find the median height of the girls in the sample and explain what this means in the context of the height of the 500 girls. So the median height, we know that the mean is 164.43. Therefore, that's halfway down the middle, and it's going to be 50% of the girls would be taller than that, and 50% of the girls would be shorter than that. Moving on to the next bit there, part C. So part C says, use the data in table 1 to complete table 2 by finding the percentage of girls in each of the height categories. So again, once they give you a figure, you can try and figure out where they got that from and then copy the method to get the rest of the numbers. So find out how they got the 22.4%. Okay, from the first table, we know between 160 and 165, we've got 112 underneath it there. So 112 is in the 160 to 165 range. So they put 112 all over the 500 girls, multiplied by 100 gives you your 22.4. And we did the same with each of the interval. So we had 15 in this category here, in this interval here. So 15 all over the 500 multiplied by 100 gives you 3%. And we did the same with each one of those, giving you 9.6, 16, 16.2, 5.8, and 2. And that is all there if you're not sure how to do them. So use the table data in table 2 to draw a histogram showing the percentage of girls in each height. So just be a little bit careful and be as accurate as you can. When I was doing it, I made a couple of mistakes, but when I was doing it, I can see that it's an interval of 3 between there, like there's 1, 2, 3. So I tried to figure out exactly where they were to make it as accurate as I possibly can, and you'll get marks for accuracy, so be careful. A histogram shows the percentage of boys in each category and is given above. John examines both histograms and comments that there are roughly twice as many boys as girls in the 175 to 180 centimetre category. Do the histograms support his claim? And looking at them between the 175 and the 180 category, I'm looking there and I can see, yes, there's about 11.5% for the boys. If I go up here and go across, I can see, yeah, about 11.5, maybe a little bit more, about 11.5% for the boys. But for the girls, when I go up here, we know that number, that's 5.8. We can see it from the table up there. So that is yes. Mary examines both histograms and comments that I see that there are more tall girls than tall boys. Do the two histograms support her claim? I would say no for this one. I find these ones kind of tricky, but I would say no for this one. There is a higher percentage of boys towards the right-hand side of the bar chart compared to the girls. So the percentage of boys over 170 centimeters is, and I just went to my chart and I got 17, 11, and 9. So over 170. So I got 17, 11, and 9, and I added all them up. And I did the same with the girls. I added this one and this one and this one up. So we did the same with the girls, and I only got 24%. Now, I say up here, this type of question is a bit waffly, and it's important to support your answer with calculations if you can. So they want to see a little bit of math. So don't just go no and kind of give a verbal reasoning. If you can actually support your claim and support what you've come up with a little bit of calculations, that would be better. Right, and this is the bit that we're currently on now. The mean height of the boys in the sample is 166.7 centimeters, and the standard deviation of their height is 8.9. Assuming that boys' heights are normally distributed, so again, this is my normal distribution curve, use the empirical rule to find an interval that will contain the heights of approximately 95% of all the boys. Now, you've got to remember that 95% is plus and minus 2 standard deviations. So again, remember 68%, 95%, 99.7%. 68% is plus and minus 1 standard deviation. 95% is plus and minus 2 standard deviations. And to revise, 99.7% is plus and minus 3 standard deviations. Okay, so you've got to know that off by heart. It's not in any tables. So 95% is 2 standard deviations from the mean. So multiply the standard deviation, 8.9 by 2, plus and minus from the mean. So we've got 166.7 plus 2 times the standard deviation. From there, it gives us 184.5. Do the same thing, but minus 2 of the standard deviations gives you 148.9, and that is our range. So that is what they ask you. Find an interval. An interval would be like a range, so that is our interval here. Last bit there. Here, the standard deviation of the heights of the girls is 7.7, while the standard deviation of the height of the boys is 8.9. Interpret this difference in the context of the data. Okay, again, this is very tricky, and I wouldn't know whether I've done enough for this type of a question. It's hard enough. The boys' heights are more spread out from the mean compared to the girls' heights. So can you see the boys have got a standard deviation of 8.9, which is a bigger number than 7.7. That would indicate that the boys' heights, the highest and the lowest, are further away from the mean than the girls' heights, which has got a lower standard deviation. So the boys' heights are more spread out from the mean compared to the girls' heights. So I went in and I looked at 95% of the data, which is plus and minus 2 standard deviations. So the boys from part DI above, which is just basically this information here, 95%, we got a spread of 35.6. So I'm just literally subtracting them from each other, and I got 35.6. So now I have to go back and do the same thing for the girls. I have to find 95% range for the girls. So basically what I've done here, I'm going to do the same for the girls. So from part BI, a couple of pages over, if you remember, we got a mean of 164.43. They're telling me my standard deviation is 7.7. So I'm going to do the 95%, which is 164.43, which I got from part BI, plus 2 standard deviations, plus 2 times 7.7, and I get 179.83, minus 2 standard deviations, 149.03, and I subtract them and I get a spread of 30.8. So that is a lower spread than the girls.